Hello everyone. In previous slide we have seen that Friedel-Crafts reaction. So we know that Friedel-Crafts reaction two types. First one Friedel-Crafts alkylation, Friedel-Crafts acylation. Now we will see that Friedel-Crafts alkylation reaction. So the Friedel-Crafts alkylation reaction to the replacement of aromatic proton with an alkyl group. This is done through an electrophilic attack on the aromatic ring with the help of a carbocation. The Friedel-Crafts alkylation reaction is a method of generating alkylbenzene by using alkyl halide or a reactant. So now you see this reaction. In that reaction, so benzene react with alkyl halide, that is RCl. Cl is that your one type of halide group. R is the alkyl group. It may be CH3, C2H5, or you can increase the number of carbon, you will get your alkyl group. Halide group, you can use chlorine, bromine, iodine, any one. So that methyl iodide, propyl iodide, propyl chloride, methyl chloride, propyl bromide, methyl bromide, or maybe ethyl bromide, any kind of this alkyl halide you can use for this reaction. But in presence of one strong catalyst, that is Lewis acid, that is AlCl3, then only from that benzene ring one hydrogen will be replaced by alkyl group and the byproduct will be HCl. So a Lewis acid catalyst such as FeCl3 or AlCl3 is employed in this reaction in order to form a carbocation. So whenever will see that, that means whenever I am going to explain that mechanism, that time we will see that how during that reaction we'll get that carbocation. So once that carbocation will produce, that will be facilitating by the removal of this halide group. The resulting carbocation then undergoes the rearrangement before proceeding with the alkylation reaction. Now see the mechanism of this reaction. In the first step, that Lewis acid, that is the catalyst, undergo the reaction with alkyl halide, resulting in the formation of carbocation, electrophilic carbocation as an ion pair. So in that reaction, AlCl3 and this RCl, that means Cl also having that excess number of electron, it can be easily donates that electron to that Al aluminium and to form a ion, right? Carbocation. So here that is small mistake is there, you see, that is once this Cl, that means it will break down here only R and Cl, that bond is there, that bond will break down, that means whatever bonding electron is there, both the bonding electron goes to that chlorine atom, as because as you know there is alkyl group containing carbon atom is less electronegative as compared to chlorine, that is chlorine is your 3.5 electronegativity, whereas 2.5 is your carbon electronegativity. That's why both the electron will goes to that carbon chlorine atom, and then chlorine atom will attach to that Al atom. So that's why you will get your AlCl minus plus R plus. R plus means, that means elimination of proton or removal of electron. That's why it's less number of electron. That's why it will become your carbocation. Cr, that means CH3 plus. That is CH3 plus plus or R plus plus AlCl4 minus. In the second step, then this benzene ring react with carbocation. As you know that these both the carbon atom having the same electronegativity, that one of the carbon atom will withdraw the both electron, that is bonding electron, whatever pi bonding electron is there, both the bonding electron will shifted towards this carbon number 1 or maybe carbon number 2. then one carbon become that positive, another carbon become your negative. That means which one carbon, that means carbon which is withdraw the both bonding electron towards this carbon atom, that carbon become your negative charge, another carbon become your positive charge. Once this carbon become your negative, that means excess number of electron is there. That's why it can easily donate this pair of electron to that carbocation. Once it will donate this carbocation pair of electron to that carbocation, that means it will produce or it will form one covalent bond, that is C bond R. And H is also present in that molecule, benzene structure. Then after getting this carbocation, you will get your another two types of resonance structure. By this resonance structure, this carbocation become a highly stable carbocation. That means this compound showing that the different types of carbocation. By this carbocation only, that means a resonance structure. By this resonance structure, we can easily understand that benzene is your, whatever carbocation we got it, that carbocation is a more stable carbocation. Now in the step number 3, in that case, that is AlCl4 is present inside that reaction mixture, that is the another nucleophiles. So when the nucleophile attack to that carbocation, that is benzene carbocation, so from that benzene carbocation, it will release one proton. Once it will release that proton, that whatever bonding electron is there, both the bonding electron will be shared between this carbon and this carbon. That is carbon number 1 and carbon number 2. Suppose this carbon number 2 become a positive charge. So this positive charge will be eliminated once this double bond, that means this bonded electron will be acquired by this carbon atom and that carbon atom, and then they will form this bond, pi bond. And after elimination of proton, this proton will present inside that reaction mixture along with that AlCl4. Then AlCl4 will release that Cl minus, and then this Cl minus will accept that proton, whatever proton is present inside that reaction mixture, and you will get your HCl as well as AlCl3. This is the catalyst. So an illustration describing the mechanism of the Friedel-Crafts alkylation reaction is provided above. Just you go through that reaction mechanism. So this is very easy reaction mechanism. So then, okay, then thank you.